Okay. Hey guys, my name is Jan from DoraHacks, and welcome to the first workshop of our Zenrock chain and the zrSign Hackathon. And as I mentioned, it's the first workshop today. Before we start, I will give you some background of this hackathon. As the largest Web3 developer multi-chain incentive platform, it's an honor for DoraHacks to support the Zenrock chain and zrSign Hackathon. And we're looking forward to seeing all the incredible and amazing projects building on top of Zenrock chain. Today, we're very happy to have here Chris, Martin, Venemir, Val, and Jason from Zenrock Labs. And so without further ado, let's welcome the guys to start. And for the audience, if you do have any questions, do not hesitate and drop them in the comments section on YouTube or Binance Live. So whenever you're ready, feel free to start.
Great, thank you, Jan. So I'll kick us off today. We had our opening ceremony on Monday, and hopefully folks found that useful as a way to get started. First thing I wanted to do today to just kind of kick us off to see if there are any questions from the audience and from the hackers that have started their quests as part of the hackathon. So I'll give us just a couple minutes to see if there are any comments that come in. Otherwise, what we're going to do today is do a deeper dive on zrSign, which is kind of our flagship product for interacting with our NPCs. And in particular, what we have deployed right now is a version of zrSign called zrSign Direct, which is a direct integration with our NPC infrastructure on the back end. So if there are no questions that I see come in pretty quickly around pointers and other things that we can do to kind of help developers move along with their quests as part of this hackathon, we can go ahead and turn it over to Venemir, who's going to take us through more of a live demo and talk through some of the example use cases that we have built out as we have developed the zrSign Direct product.
Yep.
I'm not seeing any questions right out of the gate. So Venemir, do you want to go ahead and share your screen out and take us through some zrSign examples and use cases?
Okay. So I've prepared a small demo here. As I mentioned on the opening ceremony, I would love to see more autonomous Web3 future controlled via smart contracts, immutable smart contracts. And in today's demo, I would like you to show you a test example of what I call zrSign facet, cross-chain facet. So what does this contract do is literally it's connected to the zrSign contract. It can request a new way. These EOAs we will use as pools. And so the users and the developers will be able to send their testnet coins asset to that dApp and to exchange them for another testnet coins assets. So for example, in today's demo, we have Sepolia chain ID and Amoy chain ID. So we'll be able to exchange our Sepolia ETH for Matic autonomously. So what we have here, we have a zrSign Connect library. It's in the docs. You can use it because you receive the direct connection to the zrSign. You don't need to handle that. Just inherit the contract and focus on the business logic in the contract. So what we will see today, we will see two types of transactions, RLP encoded transaction and simple transaction. So I've just deployed the contract and let's start. So Sorry. Yeah. So here is the contract, quite fresh. I haven't tested it, if I should be honest. Yeah, maybe we should verify. No, it's not a proxy. Okay, cool. So the first thing is to request EVM wallet. So what I will do is I will simply request an EVM wallet with options 1. This means default EOA without monitoring. So this wallet, this public key, this EOA won't be able to use a simple TX because it's without monitoring. Okay, I will need to send some Sepole ETH here as well to the contract. Come on, Sepole. Yeah. Okay, let's do that via remix. I will just connect to and add address. We don't have a contract here. Let's do this. Nope. This won't work. Maybe my MetaMask is. Let me. Nope. Okay, I'll try another browser.
Just you could also try shutting down the extension and turning it on again.
Yeah,
that might work.
I guess I will shut down the whole Chrome. Okay. Okay, the curse of too many passwords. Let's hold the contract again. Copy it and fund that contract. Why we need to fund it? Because this contract needs to pay the fee, the zrSign fee. I don't know.
Can you, if you click on the estimated fee, I think it's having issues.
Yeah,
estimating the fee. So if you can manually update the fee somehow.
I cannot.
Vladimir can also send me the address and I'm gonna fund it from my wallet.
Okay, I will stop sharing for a while. Yeah, just fund the wallet, please.
I have the same issue actually.
You have the same issue?
Yeah, I cannot
send. I will redeploy the contracts now.
Okay.
So Yeah, let me clean that. Deployment. Okay. I'll share my screen again. So here we go. It's quite important to have this receive function to be able to fund the wallet, or you can go to zrSign Connect here and the library, and you'll see that the request new EVM wallet is payable. So you should be able to send funds within the transaction to request a new wallet or a new signature. But yeah, we'll use these two. So get Sepolia ETH and get Amoy Matic. When we create a new EVM EOA account, we need to fund that because we will use it as a pool at Matic, at Amoy. And then this contract will be autonomously be able to create transaction and controls this EOA when receives, for example, Sepolia ETH. Let's check what's going on here. Yeah, the contracts are deployed. Now it should verify. Okay. Here we go. Okay. This time we shouldn't. Yeah, now is okay. I will send 0.1. It should be enough. Confirm. So once the contract receives that, I will be able to request a new EVM wallet. Request new EVM wallet. We can send the fee within the transaction, or we can choose to not do that. So this contract is directly connected to the zrSign contract at the moment. And right now, we are okay. So executing this transaction, this means that this DApp will request a new EOA wallet, and only this DApp will be able to control these EOA wallets. So my EOA account won't be able to control these MPC wallets. If we see the transaction, you'll be able to see that this DApp internally will call zrSign key request. zrSign will accept the request, and we know that because we're on the same chain. And yeah, and then on the response, because we've paid the fee to that contract, to zrSign contract, the change will be returned. Yeah. Okay. Cool. So now here we go. You can see in the internal transactions, we have a new key request, We are waiting for a key response, and we should be able to see here get EVM wallet by index or get EVM wallets. As you can see, I've already have a generated EVM wallet, and this wallet, this UA account, will be under control of this dApp. So if I fund that wallet in Amoy, let's say Amoy, let's send 0.2 Matics, or maybe more, 0.2 more. Okay, so if I come back to Sepolia right now, I will be able to get Amoy Matics by exchanging my Sepolia ETH. So for example, if I have exhausted all my facets on Amoy, but I have Sepolia ETH, I can trade them within this contract by simply send my Sepolia ETH here. The contract will encode the transaction and will instruct this pool that we've just funded to make a transfer for the same amount. Well, it's not the same amount because it will subtract the fees that will be paid, but it's almost the same. So if I send here 0. For example, 2 ethers. Yeah, okay, 0.3 ethers. Let's say, nope. Wait. Yep. Nope. Why is that? Oh, we need to wait for the wallet. Okay, key response. Yeah, we have key response. So 0.3. I will try it. We will see. And then I will request a new wallet with monitoring options to be able to use simple transactions. This is where we'll be able to use our zrSign simple. Oh, that's why it will throw because I'm not using the correct wallet. Okay, 0.3 here. Yeah. I need to wait. So what's the difference? My first wallet that I've requested it as a default wallet, and the default wallets cannot use simple transactions. Only the plus wallets can use simple transactions. And I've requested a simple transaction with a default wallet, and that's why the contract will throw. But yeah, anyway, right now I am sending this, and you'll be able to see that my my EVM wallet here at Amoy so we have 0.4. I've sent to the facet 0.2 Sepolia ETH. So the facet will accept that, will contact zrSign instructing to send me 0.2 minus the fees, and will broadcast the transaction autonomously. Yeah, The contract accepted 0.2, as you can see. So the transaction is successful. And right now we are waiting for a signature here, which is zrSign response. And once that sign response is here, the OVMs will consume that and will broadcast the signed transaction to the Polygon scan. And let's see. So while we're waiting, we can test the simple transaction, because right now we have a wallet. So if I send 0.1 here, yeah, you'll be able to see that this time will be successful because I've requested a plus wallet, which is this one, the second one. And we need to fund that as well. Yeah, here. I can share the code with you if you want. Jason, we can upload it to GitHub as a...
Yep, we should.
simple dApp.
Yep.
Okay. We are waiting. Yeah. So the zrSign is contacted, but something is wrong here. I don't know why. I need to check out. Let me check out. So we are preparing a logs dashboard with logs where you all will be able to check out what's going on and how your transactions are. And yeah. I need to investigate a little bit more, but yeah, we'll share that with you as a demo. And I will.
I would say, like, if there's any questions in the meanwhile from the audience, feel free to drop them, and then we could also go through it.
Can also recap the flows of what you were walking us through. Excuse me, Denimir, to kind of zoom out, talk through exactly kind of the flow that you were demonstrating, and then kind of where things are currently. So we were doing a swap basically from Spolia ETH to Amoy, right? So if you can talk through a little bit about like what the zrSign contract is doing, what's going on in the back end, interacting with the NPCs, etc. I think at least understanding the flow, obviously, a couple of things we need to dig into with the logs and this reference DAP, but if you can talk us through the scenario, I think that would be useful.
So if we have a DAP that is connected to zrSign, so this DAP first should generate a wallet. It doesn't matter. It could be an EVM wallet. It could be a Bitcoin wallet, right? So when the DAP is connected to the zrSign and the DAP requests a wallet, zrSign contract will emit an event, and these contracts are monitoring from connectors to our NPCs directly. So the connector will consume those events, and other connectors will acknowledge the events, and then the NPCs will be triggered to generate a key or generate a signature. Once the key is generated, the key is returned directly to the contract, so it lives in the contract state. That's why we are able, as a DApp, to query the zrSign contract and see our keys, our pools. So from that moment, the DApp will be able to request signatures, and you have two options to request signatures. The first one is you should encode. Do you guys see my screen? Yeah, you should encode.
We can't see your screen.
You can't?
Now we can. Now
Okay.
we can.
Okay. So with the zrSign Connect library, you inherit the ROP connection, the ROP library, the ROP library here, and this library will help you to encode transactions. And so if you want to make a transaction, you can use simply encode transaction and ROP encode transaction, where you are passing the nonce, gas price, gas limit to value and data. And this will return a byte array, which is ROP encoded byte array, and you can pass it as a payload here in the request zrSign for TX. So for example, here what we do is we're encoding the data field with the blockchain ID because we want to know which is the source of the chain ID. Then we estimate the fee, and then what we are doing is we are subtracting that fee that we pay as a DApp from the message value, and then we are encoding the ROP encode transaction within the contract with the nonce, with the gas params to value and data, and then we request a signature for transaction. For example, EVM wallet type means that we want a signature for EVM, the wallet index 0, destination chain ID, which is AMOI, destination chain ID, because when we say get AMOI, we are passing destination chain AMOI. We inherit KIPes. We are inheriting KIPes here for generating these chain IDs, and then just a request signature from which wallet to destination chain ROP transaction data that we've just encoded. Then this request will emit an event. The connector will consume that event, will pass this ROP transaction data to the NPCs. The NPCs will sign that data, and then we'll return the signature directly on chain within the contract. So submit simple transaction is much more simpler because you don't need to encode the whole transaction, ROP encode transaction. This will happen off chain, and a part of that, you don't need to manage the gas params at all, even the nonce. So we are monitoring that wallet, and so the connectors are monitoring that wallet, and you need to pass only 2 value and data. So if you can see here, a request sign for simple TX is 2 value and data. This is the that's the struct here that we are passing. So the zrSign Connect library will encode that and will convert it into a payload. Then the connectors will be able to decode that and fetch the necessary data and sign that and broadcasted it. So that's the difference between simple and ROP encoded transaction. With simple, you don't have such control, like managing the knowns, speed up transactions, and so on and so forth. But it's a little bit more cheaper from the ROP encode transaction on chain. So yeah, that's it.
Good.
So
Thanks. Thanks, Venomir. Not sure if you had any other kind of thoughts on the demo or kind of what you want to do there, but we can certainly circle back to that. We've got a few other workshops that are scheduled, so we can run through those again and maybe have a little bit more of a streamlined end-to-end flow. But I think we get the gist of what's going on there. Do we have any questions from the audience?
Yeah, maybe let's give the audience some time. There will be also the chance to watch all the videos or workshops asynchronously. For the audience, if you haven't joined the Zenrock Labs Discord channel, it's also like in the YouTube comments. One thing to mention again is like there will be more workshops on the 22nd of July, 24th of July, and 26th of July. So if you do have like any questions, I think it's best if you get on the Zenrock Discord and ask them there directly. Is there like anything else you would like to add here, guys?
I don't have anything else to add. I just want to emphasize that, this first version of zrSign is the product that we refer to as zrSign Direct. That's direct access to the MPCs. There are further enhancements that are coming, and another version of zrSign, a separate smart contract that's zrSign Omni that will interact with the Zenrock chain, and we'll have another workshop where we talk about kind of the unique characteristics of it. But as we go through this, I think what you see right now is that with zrSign, we're able to interact with our NPCs, create addresses across multiple chains, transfer assets across those chains. All this is done without the need for bridges and typical cross-chain transfers that you see. This is also carried by our NPCs on the back end. And once we have the zrSign Omni capabilities in place, you'll be able to also leverage the constructs of zrChain as well. So more to come with that in some of the future workshops we have teed up. But yeah, that's all that I would add. Anything else from the other guys on the call? Martin, Chris, Val?
Nothing from my side.
Nothing from me at this point.
Okay.
Okay, then I would say we
All
can
right.
wrap it up. So
Yep, we can wrap it up.
for the
So
audience,
Jan,
yes.
sorry, I was just going to say, so for those that watch async, do we collect questions from the audience async as well, or will those all funnel in through Discord and the other channels that we have set up?
So people can watch it asynchronously on YouTube and Binance Live, but I would suggest that they go click on the Discord link and then join the Discord and ask questions over there.
Yep. Good.
Okay. So I think we can wrap it up. So thanks a lot for the workshop today. There will be 3 more workshops, maybe more. So feel free to also subscribe to our YouTube and Binance Live to not miss out on any of the upcoming sessions. So thanks a lot, guys, for joining us today, and hope that you're building something incredible that's useful for our industry. So see you guys at the next workshop, and thanks a lot.
All right. Thank you.
Thank you.
Thank you.